Good morning, good afternoon, good evening, wherever you're joining in from today. Welcome to another live sessions at the Reactors. My name is Rav and I'm the Program Manager at Reactor London. Before we get into the session, please take a moment to read our code of conduct. We're all here to learn, so please be friendly, please be professional, and please be kind and considerate to people's comments. The chat is open throughout and we do encourage you all to participate. Today, we're back again with another episode of building your startup using Azure. And today's episode, we're going to talk all about anomaly detection. And this session will be led by Nikhil. And with that, I'm now going to bring him up so that he can introduce himself. Hi, Nikhil.
Hi, Rav. Thank you for the introduction. And hello, good morning, good evening, good afternoon, everyone. So great to be back with another episode of Building a Startup on Azure. So just to introduce myself, my name is Nick. I'm the CEO, founder of Vast Minds, which is a Microsoft for startups company. And I lead most of the R&D at our company with a background in AI engineering. And our company is primarily built on Microsoft Azure. So I'm super excited about all of the services that Azure has to offer. And my purpose with these series is to show you how to piece them all together so you can build an end-to-end solution that is commercializable and that you could take to market. So with that, I'm going to go ahead and share my screen. So Rav, just let me know if I run into any issues. So let me know if you can see my screen, Rav.
Yes, we can see your screen. Yes.
Awesome. Okay, great. So just before we jump into the anomaly detection service, which is the cognitive service we'll be using to solve a problem today, I definitely encourage you to look at the Azure Cognitive Services suite. It is a great suite of AI tools ranging from language to vision tasks that you can use to build any kind of startup, really. So definitely encourage you to check this out. But for today, we will be focusing on one cognitive services application, and that is anomaly detection. And we're going to use that to solve a pretty important problem today. And that problem is healthcare related. So one of the biggest problems today in the healthcare economy is the amount of problems that arise from cardiovascular disease. And that is this disease, this chronic disease, represents not only over 30% of deaths worldwide, but it's expected to cost, I think it's expected to cost the global economy over $1 trillion by the end of this decade. So it's a significant cost, well, a significant problem that poses a significant cost to the global healthcare system. And we're actually going to use a simple workflow to help spot early signs of cardiovascular disease. So this type of chronic disease can be prevented and treated early on. So it doesn't pose the economic costs that it generally does if not spotted early enough. And this is the reason why we're going to use the anomaly detection algorithm. It is a way where we can detect anomalies in someone's physiological data and really help to understand at what point could this person start developing symptoms that could be an early sign of the onset of cardiovascular disease. And that's really the whole point. That's really the whole point of anomaly detection. It's all about spotting early signs of anything, right? So if you have a series of data, whether that be physiological data or something else, if generally anomalies occur, those anomalies could be a sign of something bigger to come. So it's such a, it's actually a simple workflow, but it's a very important problem to solve. And so what's the solution here? So what we're actually going to do is we're going to ingest physiological data, and this could be from a wearable, or it could be from a smartwatch. It could actually be from systems at a hospital. So generally, when patients are at a hospital, they're hooked up to what's called cardiac monitors. And those cardiac monitors are monitoring a range of physiological information about the patient. So it could be their heart rate, their blood pressure, their respiratory rate, their oxygenation. And you probably, if you've ever been to a hospital or an ICU, or even watched movies about this, you'll probably see those big monitors by patient's bed, which are monitoring all of these values in real time. So, this is a great application for anomaly detection, because generally what happens is that doctors go around to these monitors and actually manually record or manually see if anomalies occur. So wouldn't this be great if we could build out a solution that automatically ingests all of this data and tells us when anomalies can occur? Because ultimately that could save lives in that situation. So anyway, this is the overview. We're going to ingest physiological data, and we can generate some synthetic data for this example. We're going to use the Anomaly Detection API to search for anomalies in that data. And we can build alerts when an anomaly occurs, so early prevention can happen. And this is the architecture. It's actually extremely simple. What we're going to do is we need to get this data from a source, and in this example, we'll be using synthetically generated data. We'll be parsing that data, so there is, data that is obtained from a source is always not in the best and correct format. There's always some parsing that needs to be done to that data. We're then going to feed that data into the Azure Anomaly Detector, and I will show you how to set that resource up in Azure Portal. But this is what we're going to do, and we can use the output from the Anomaly Detector API to generate alerts. So this is the basic premise of what we're going to build. The architecture for this is, relatively simple, and that's the whole benefit and promise of the Azure Cognitive Services suite. You don't need to build out a complex architecture to build a solution like this. You can just leverage the existing APIs that are available. So let's build it. This is the most exciting bit. And what I would always encourage you to do before you check out these cognitive services, I would always encourage you to look at the API documentation. So this is listed in the Cognitive Services webpage, and you just select Anomaly Detector. I would definitely encourage anyone to just spend at least, I would say, 15 minutes going through some of the quick start tutorials, and also just have a look at what is Anomaly Detector. So have a basic understanding of what it is, and how it's doing what it's doing. And that's something we're going to have a look at. So if I just click on what is Anomaly Detector, let's actually find out what it is. Okay, so in principle, we have two capabilities. We have a univariate anomaly detector and a multivariate anomaly detection algorithm. Right, I'll zoom in just so you can see this a bit better. Univariate, to put it simply, all it means is it takes a single variable. So we could look at heart rate data over time, and it detects anomalies in that single variable. That's what univariate means. Multivariate is a little bit more complex, and what it does is it takes in multiple sources of data. So it could be, in the ICU example, we could take streams of heart rate information, respiration rate information, blood pressure information, and detect anomalies in those variables and actually alert the physician or the clinician. So that's an example of multivariate, when you have multiple sources of information. Univariate is when you have a single source of information to detect anomalies in. And so the way that the univariate anomaly detection API works is it will detect anomalies in a single source of data. This is an example of multivariate anomaly detection. So you're looking at multiple sources of information and detecting anomalies. When those sources all move in a certain way, that creates an anomaly. And okay, so that is just a basic overview of what anomaly detection is. We're also, without getting too technical, I do think it's worth looking at just an example of what the underlying algorithm does. Now, this does get quite technical and scientific, so I would definitely encourage you to have a look. Don't worry if you don't understand everything, but it's definitely worth a look. So, if we actually look at the mathematical definition of what anomaly detection is, it is given a sequence of real values, so x1, x2, all the way to xn. The task of anomaly detection is to produce an output sequence. So you'd have a corresponding y value for every x value, where y is either 0 or 1. And that 0 or 1 will denote whether x is a anomaly point or not. And actually, the interesting thing behind the anomaly detection algorithm here, if I just show you actually the algorithm behind the Azure Cognitive Services Anomaly Detection API, it's something called a spectral residual convolutional neural network, or also known as an SRCNN. And this is kind of the basic architecture of what it does. So it is a so what it does, and just to explain this pretty simply, is it takes a time series input. So this could be, in our example, this could be a heart rate signal. Let's just look at the diagram here. It could be a heart rate signal, and then it calculates the spectral residual. So if you don't know what this is, think of it as a representation of what frequencies are present in a signal. And what you'll find, and really what that means, is when you find points of anomaly, they create funny frequencies which don't really correspond to a baseline frequency of a signal. So from the frequency perspective, you get weird spikes that happen in what's called a saliency map, which is a representation of frequencies. You get these weird spikes, and this is very obvious to see from a frequency perspective, not so much from a time series perspective. And you can run this saliency map, through a 1D convolutional to get a sigmoidal output. And that sigmoidal output is a value, if you don't know, from 0 to 1. And sigmoid, using a sigmoid output for any neural network is actually pretty common. And it's usually used to denote the probabilistic value that something is something. So that the sigmoid output could be 0.8, and that would indicate, we would probably round that up to 1 to indicate the probability that there is an anomaly. So that's just a quick overview of the algorithm. Again, it's not necessary. It's useful to know. It does get pretty technical if you look at the underlying algorithm, but that's not necessary. But definitely encourage you to do that. Another thing you could do, which is super useful, which Microsoft, in my opinion, have done super well, is just look through the quick start. So today we're going to be coding in Python. And the Python quick starts are very, very simple to follow. It will tell you how to set up the Azure Anomaly Detection resource, what variables and environment variables to include, and some quick code bases that you could use to start generating some some useful outputs from the API. But anyway, we're going to cover all of this today. So back to our architecture. The first thing we need to do is we need to actually build an Azure anomaly detector resource in Azure. And the way we would do that is you would head over to portal.azure.com/home. And what you want to do is you want to head over to Cognitive Services. And here, right, here's actually a good example of all of the services that you can see available within Cognitive Services. So I have speech services, other services as well. But for the purposes of this tutorial, we're going to look at the anomaly detection resource, and I would click Create. And here it's a very simple setup. You would choose your subscription. So I assume if you're part of Microsoft Founders Hub, you will actually receive a sponsorship subscription ID that has a certain number of credits associated with it. So it's a great way to get started at zero cost with this resource. And then you would create a resource group. A resource group is just a collection of resources that relate to a specific product. And you could name that anything. So you could name that, I could say, create new, and just could be, let's say I'm creating this anomaly detection resource for a hospital. So I could just say anomaly hospital resource. Right? It doesn't really matter, just something unique and something that will hold a collection of all your anomaly detection resources. Region East US, again, doesn't really matter. Put it somewhere. But you may encounter, let's say when you go to market, an important note is that you may encounter some clients. So if we were marketing this solution to hospitals, we may encounter some clients who are based in other regions, which are very sensitive about processing data in a region outside their jurisdiction. So for example, just in my own experience with Vastminds, we serve clients around the globe. But we have had to spin up resources in specific regions where the client resides. And that is because data sensitivity is a hot topic right now. And some clients don't want their data being processed in a resource which is outside of their jurisdiction. So Azure pretty much has every region you can think of. We can deploy this in Australia, Brazil, Canada, Central India, East Asia, you name it. So this really should cover the entire globe. You just need to just be cognizant of deploying a resource wherever your customer or your consumer will be. But we'll stick with East US for now. And then we could we could come up with anomaly detection resource. It's fine. And then pricing tier, you can start with a free one. Why not? Just start with a free one. If we look at full pricing details, yeah, okay. So here's the pricing details, right? So you can see you get at least 20,000 for the free version. You get 20,000 transactions free per month. So that it's just more than enough to get started. I'm pretty sure you won't be doing over 20,000 calls, but if you manage to actually productize this whole product and take it to market, you could be actually doing well over that. And that's when you'd move over to the standard package, which is, in my opinion, you're looking at 31 cents per 1,000 transactions. That is pretty good and well competitively priced. But anyway, that's this is how you can click review and create, and that is it. You're ready to go. So what will happen? I already created one earlier, so I'm going to discard this. What will happen is you'll end up with something that looks like this. So it shows you which subscription you've attached this to, which region you've attached the where you've deployed the detection resource, pricing tier minus free for now. Then you also have keys and endpoints. And really all you need to do is you need to, if we look at the quick start here, let's see what it says. So go to quick start. Okay, Python quick start. Great. Okay, so all you need to do is you need to, and I'm on Bash. So all you need to do is you need to set the anomaly detector API key and replace it with your key value. And then you need to export the anomaly detector endpoint. And you'll find that if you go to the resource, which is anomaly detector, and you go to keys and endpoints. Now, I'm not going to show you my keys because that is a secret, but you'll find these keys here. So you can just copy to clipboard. You can also copy this endpoint and store them as environment variables. And then you are pretty much good to go. So that is all you need to actually get started on with the anomaly detection endpoint. So great. So now the resource is set up. We're pretty much ready to get into the code. We just want to check that everything is running correctly. That's fine. Okay, great. So if I bring up my VS Code, and I'm going to zoom in a little bit so you can see this well. Okay, great. Now, the first thing we need to feed the anomaly detection resource is we need we need some data. And that data has to be in a certain format. So again, I would encourage you to look at, if we go to Quick Start, and if we go to Best Practices, and we can look at Univariate for now. This is quite important because it tells you the exact format in which the timestamp should be. So this timestamp actually follows the ISO 8601 standards. So you'd have a date, you'd have a time, and with a Z at the end of it. So this tells you the exact timestamp that you need. But anyway, I actually have some code here that will generate dates in the exact timestamp you need. So this is it's in compliance with ISO 8601 standards. So what this code will do, we're going to take this step by step. So what this code will do is it will generate a list of timestamp values. So what we need to do is we need to generate some synthetic data so we can feed the anomaly detection API. And once we have real data from a hospital or from a wearable device, we can simply replace the data with that and run the algorithm, and it would work just as well. So the first thing we want to do is we want to create a list of dates, and I'm going to comment out everything initially, and we'll go through this. Okay, so you'll see what we have. A list of generated dates from the 1st of March 2022 to the 15th of March. And we're going to do this every hour. So we're going to generate a date timestamp, every single hour. So we'll have about, from 15 days, we'll have, over 300 samples. And then what we need to do is we need to generate some associated data. Now, I've created a small code block here. But by the way, just to reiterate, all of this code will be available on GitHub. The link will be shared with you. The whole point is that you don't have to recreate this from scratch. You can simply use this and actually use this to either get to a product that you can take to market in the fastest possible way. So what I'm doing here is I'm synthetically creating some data. So I'm generating some heart rate data using the NumPy library, random normal. And this just generates some data centered around a mean value of 70 beats per minute, because that is generally, an average value, I would say. It should have the same length as the dates list. And then what we're going to do is we're going to store that to a pandas data frame, and we're going to have that data frame reference two columns, which is timestamp and value. We're going to then insert some anomalies. So we're going to insert some anomalies randomly, and we're going to do that at the start. So we're going to insert some anomalies at the start, so from indexes 5 to 10, and we're also going to insert anomaly at the end. So This one is a hard-coded anomaly. We're asserting 100 BPM. And then what we're going to do is we're going to save this to a CSV file, and we're going to save this in a path that we can reference later. So you can see we'll save this to this path. In this folder, we'll save a CSV, which is heart rate data. So let's run that. And so that will save that to heart rate data. And what I will do is I will just show you, if I click in sample data and look at heart rate data, this is what it's generated. So it's generated a timestamp value, and for every corresponding timestamp, it's generated a heart rate value. So you could see for this patient, in the first hour of 1st of March 2022, this patient had a heart rate of 67. Right, very simple. And then you could see corresponding heart rate, so 70, 71, 74, 67, 92, 125. Now these two look, so if a patient's heart rate was trending at around 70 and jumped to 92 and 125, it would be very prudent to catch that. So when we run this data through the Anomaly Detection API, we hope that we're catching these values because they seem like anomalies to me. And then, we can see some pretty high values here, 101, before we start going back to 70 beats per minute, which is relatively normal for a resting heart rate. Okay, great. So we have the data in the correct format, right? And you can use this code as well, which will be available in GitHub to generate your own synthetic data or replace this with real data. If you do replace this with real data, you just want to make sure that the data looks like this. And so you want to have a timestamp in the ISO 8601 format, along with a corresponding value. Okay, great. So we've generated some synthetic data. Now it's time to detect some anomalies. So I created a script here called Anomaly Detector Entire. And again, I'm going to take you through each step in this code. So the first thing we want to do is we want to load our environment variables, and just recall from the start that we had to set our API key and endpoint, which, just to remind you, you can get from, if we look at the portal, go to keys and endpoints, you would just copy the API key, you'd copy the endpoint, and you'd store them as environment variables somewhere. Once that's done, you will have to reference a data path. So recall that we generated some synthetic data for heart rate. And so what we're going to do is we're going to copy the relative path of this. And we're going to put this in our data path. So let's just replace this string for sanity's sake. So you can see we're now referencing the sample data, heart rate data. There's some other sample data which I referenced as well, according to other physiological parameters, but we'll get to that later. The next thing you want to do is you want to initiate a client, anomaly detector client, and you can do that using the anomaly detector client class here, which is the Azure class, which is imported from this library. So azure.ai.anomaly detector, you can import the anomaly detector client class. And you just need to pass the API key using the Azure key credential class along with the endpoint. The next thing we need to do is we actually need to convert the time series data into what's called a time series point class. And this code block does exactly that. So what it does is it starts defining an empty list, which is called series. And then it grabs the data file. So we actually read in the data file. We read the CSV here, again, nothing fancy. And what we're doing here is we're appending to the series list, we're appending the first row, which is the timestamp and the value, but we're appending this as a time series point object. And the reason why we have to do this is the required format for the anomaly detection API. So again, this code is already built for you. You don't need to recreate this. Just make sure you get your data path right. Then what this block What this block of code will do is it will read in the data path, read in the CSV file, and start appending each row in the CSV to this series as a time series point object. Then what we do is we define a request, which is detect request, and we're going to detect the series. And recall that the granularity of the series, this is very important, and this is where actually a lot of errors can occur. You will need to specify whether the frequency of the sampling rate of your data. So now, if I look at my heart rate data, I can see there's a row for every hour. So at 1 a.m., at 2 a.m., at 3 a.m., at 4 a.m., and so on. So you want to make sure that the time granularity is specified to hourly. This could also be, bear in mind, it could also be daily. It could be per second. So we could do per minute, per second. So it's very important that you get this attribute right. But in my case, it's going to be hourly because we generate the data on an hourly basis. And so there's two key things that you can actually do with the anomaly detection endpoint. By this point, the anomaly detection endpoint is already set up. It's referenced our keys, our endpoints, and we're ready to start detecting anomalies. One of the things you want to reference as well is what's called a change point response and an anomaly response. So a change point is when is detecting a point. So I'll just put this in the comments so you can reference this. This is a point in the time series where the data, where the trend, let's say trend changes direction. And this one, given the name, is a point in the series where the value is anomalous. Right, so a change point is useful when you're looking at trend data. So, in the case where we're looking at heart rate data, for example, we do want to see if, let's say, if heart rate is trending downwards, we definitely want to see a change point. So we can see that actually the trend of someone's heart rate is trending downwards, which could be actually quite a fatal sign. So if someone's heart rate starts declining rapidly, we'll want to identify a change point, which is a change in the trend, to notify a physician or clinician. And what I did here is detect. Yeah, actually, we're going to ignore detecting the last point for now. So all you're going to worry about is we're going to run this request over the entire series. So we want to detect what this will do is we'll detect anomalies across the entire series. And this code block is useful for plotting data. So what I do here is I define empty lists for the X and Y points of both anomalies and change points, so that when we're iterating through the values, we're appending X and Y points to these lists. And this is really for the purpose of plotting the data, nothing else. By this point, we would have got our anomalies, right? So at this point, we've already got our anomalies. Now we just want to make sure we can plot it to see what's happened. So what we're going to do is I'm going to make sure our heart rate data is referenced, and we're going to run this code block. And you can see here, we're going to run this entire thing, and we're going to start plotting anomalies. Okay, so let's run this and see what happens. Okay, great. So it looks like we have a successful response from the API. And you can see in the terminal here, we have anomaly detected at index 5, 6, 7, 8, 9, and 336. So right at the beginning and right at the end. And it looks like it's got it right. So you can see if I just maximize this. The timestamps for some reason have come out as 1970, so I need to look at that. But if I, you can see this graph. The red points are every point where the anomaly detection API has spotted anomalies in this user's heart rate trend, and it looks pretty correct. So we have some big spikes here. So this user or this patient experienced a big heart rate spike at the beginning, and we've detected these anomalies correctly. So imagine if a patient was lying on an ICU bed and we were monitoring their heart rate, we would definitely want to alert a doctor or physician at this point where multiple anomalies occur in succession. And then you could see the heart rate kind of normalizes. It's a bit messy, but at the end we have another spike. And again, we've now successfully been able to detect anomalies in this user's heart rate signal, which is great. It's fantastic. It's it's something that we didn't need to build out an anomaly detection service ourselves. We just pulled in the API from Azure Cognitive Services, and especially if you're monitoring a patient with a patient's heart rate over time, this could really save a clinician or physician's time to have to manually ballpark or manually visually see if any anomalies or changes in that person's heart rate have occurred. So I'm going to go ahead and close this. So this is quite a powerful tool, and we can do the same for we can do this. I actually generated similar data for blood pressure, so systolic blood pressure. You can see this is some synthetic data, so you can see this is a usual systolic value, which is 119, 121. So I could also run this over the blood pressure data as well, which is probably arguably more important. So monitoring changes in blood pressure is extremely important, just given that hypertension affects so many people in today's day and age. And if I'm able to run that, let's see if it detects. Right, great. Okay, so this is interesting now because we have change points. So let's maximize this. Okay, so this is someone's blood pressure data. Great, we detect a few anomalies. So this person's blood pressure spikes from 120 to 160, which is extremely bad, by the way. I mean, any doctor should definitely be alerted if someone's blood pressure spikes this level. But we can also see change points occurring here. Now, I'm not sure I totally agree with these change points. I mean, it's not as if the trend of someone's blood pressure has really changed at that point. But anyway, change points are not really the focus of the API, in my opinion. I mean, the focus is really actually detecting anomalies at these index points. And you can see right at the end, this patient's blood pressure spikes all the way to 200 millimeters of mercury, which is, that is an absolute red flag. So you can imagine, doctors and physicians just don't have time to monitor a patient's blood pressure in real time. And just using this simple API, we can now reduce any manual effort to actually detect anomalies, which could, potentially save lives here. And we could do the same for respiration. Let's just run that quickly. So I generated some synthetic data for respiration rate. So let's run that now. Respiration. Okay, so respiration doesn't spike as much, but there definitely are some anomalies here. So you could see the usual respiration rate of this person hovers around 17 or 8, no, 16, I would say. And you can see some anomalies are detected here. So they're not as disparate as the blood pressure and heart rate signals or heart rate anomalies even, but definitely they are anomalies and a cause for concern. So that is a way where you could detect, if you have an entire series of physiological data, you can detect anomalies. Another point that might be useful is you can also detect anomalies at the last point. So this is another way you could do this. So sometimes you may want to detect anomalies in real time. So you may not have a specific predefined dump of data with heart rate and other physiological signals. So it may be the case that you want to detect anomalies in real time. And at this point, the code remains the same with some subtle difference. So we have our API key, we have the endpoint, we have the data path, the sample data. We define the client. Everything is the same up until this point. Even we're still the same here. But if you look at this point, we are using a different method here. So this is detect last point. So if you recall, when we're detecting anomalies across the entire series, we're using the entire series method to look at multiple anomalies in an entire series. If we want to just detect the last point, we could just call this method, which is detect last point, and pass the request through there. Therefore, when I reference, let's say, some blood pressure data, what this will do is it will only look at the last point in reference to the entire series to see if the last point was an anomaly. And I can also plot that in a similar way. So if I run this script, you could see that, yes, we did get an anomaly, which is right. So detect last point only looks at the last element in the series. And you can see, yes, absolutely. At this point, the blood pressure spiked to 200, and we're detecting only the last point. So we're not looking at these points which could be considered anomalous. We're only looking at the last point. And so when you have a stream of data coming to you in a time series format, you can look at just the last point to detect an anomaly. So it's very powerful if you want to detect this in real time. And so that's the basic premise of Anomaly Detector API. Very simple to use. You simply need an API key and endpoint. Feel free to use this code. Feel free to generate your own data. If you have an Apple Watch, try pulling data from an Apple Watch to run this through the Anomaly Detector API. You may spot some strange anomalies in your own data, which would be interesting. But in essence, the architecture is very simple. We're just using physiological data. We're getting that. We're passing the data so the timestamps and values are formatted correctly. We're feeding that to the anomaly detector service, which is very simple to set up. We just need an API key and an endpoint, which we can get from keys and endpoints. And that's used to generate alerts. So you could see in that graph, we can spot exactly when anomalies are occurring to generate alerts. And really, what the main benefits of this type of tool, especially in a healthcare setting, is ultimately we can first of all save lives. So detecting anomalies in physiological data is unbelievably important and heavily underestimated in saving lives, because that can not only spot the early signs of chronic disease onset, but it can also, in an ICU format, it could also inform when something may be going wrong to a patient. For example, the blood pressure is spiking or the blood pressure is out of the normal range in which it should be for that specific patient, which in turn, reduces any manual checking. So it reduces administrative costs. It reduces any administrative costs that are associated with doctors or physicians going around to patient beds and checking whether anomalies have occurred in a patient's physiology. Because if that does happen, they do need to take there's a very short lag time between when that happens and when they need to take action, because that could be fatal. And ultimately, one of the big themes in today's day and age, especially in healthcare, is clinician burnout. This is a big problem: clinician and physician burnout. And just because the population is growing, so you have a large population which is growing and growing, but the number of doctors or healthcare professionals are not growing at a rate at which the population is growing. So if you look at the population to doctor ratio, it's growing, which means that for every healthcare professional, they have to continue serving more patients. So we need technological ways to help the staff here. So that's a basic premise of the anomaly detector. I hope you enjoyed that quick walkthrough. thank you very much for listening. Let me know if you have any questions, and you can also use this QR code to connect with me on LinkedIn. Like I said, all of that code that you saw on my screen will be available on GitHub. So I definitely encourage you to pull down that code. Try this with your own data. You can use my you can use my code to even generate synthetic data. But I would encourage you to try and pull in your own data, either this be from an Apple Watch or another source, and see what you get, or from an Oura Ring as well. I don't know if any of you have that. You can even actually look at your sleep data through an Oura Ring. So feed that through the Anomaly Detector API, and see what you come up with. But that's it from me for now. I'm happy to take any questions if there are.
So we have three questions, Nick. First one is, what is the significance of the example anomaly detector compared to an overlimit detector?
So, okay, that's actually a great question. So if you look at an overlimit detector, that is highly dependent. And I don't exactly know what you mean by overlimit, but I'm assuming here you're basing an overlimit detector on some kind of threshold. So you would, let's say if someone's normal heart rate is 70, what an overlimit detector would do is just say, okay, well, if this patient's heart rate goes beyond, let's say 80, we'll flag an anomaly. That's what an overlimit detector would do, from what I understand it. The difference between anomaly detector and overlimit detector is that anomaly detector learns a baseline over time. So let's say if a patient's heart rate is trending upwards, so it goes from 70 to 80, there is some calibration that occurs such that false anomalies are not detected. So anomaly detector, you can think of it like calibrating in real time to someone's time series data, rather than just setting an arbitrary threshold to actually detect anomalies. So that's why it's super powerful. There's some auto calibration that occurs with the anomaly detector to learn someone's baseline trend and actually automatically detect when anomalies occur, which probably results in less false positives than what would happen if you were to use an overlimit detector. So I hope that explains. Hope that answers the question.
Sorry, we have the next question from Jack. Can you please explain change points? Why are those green points change points? I think when you were demoing.
Yeah, so change points are pretty simple. Change points are just a representation of when a trend in a series changes. So let's say, for example, when we're looking at physiological data, if someone's heart rate is generally very stable, but then it drops suddenly, maybe something happens, it drops. At the point it starts dropping, you will see a green dot from the Anomaly Detection API. So that is what's called a change point. It's when a change in the trend has occurred. So it does what it says. A change point is when a change occurs. So it's it's relatively self-explanatory.
Then we have Jack's another question from him or her, sorry, they. Is the entire series request just one transaction?
Yes, the entire series request is just one transaction. So don't be concerned about it being multiple transactions. You feed one entire series into that request. That is counted as one transaction. So even though it has, that series has 300 to 500 data points, as long as you as long as you call the method once, that counts as one transaction.
And would you be able to share your GitHub URL? I think the one you shared previously was just for the email productivity app.
Yes, exactly. So this is a different product.
Yeah.
So yeah, what I'll do is just straight after this webinar, I'll make sure that the GitHub for the new product is updated. I'll send that to Rav, and then Rav, I think you can send this out to
Yes.
any attendees that are interested.
So if you've registered through our website, you will receive a follow-up email in which there'll be all the resources for this event. And I think we've got one last question from Jack. How accurate is the algorithm? Can I run highly critical applications with this service?
Yeah, actually, Microsoft published a paper regarding the algorithm behind this, which is called an SRCNN. So definitely try and run highly critical applications. I would say actually I think there's some interesting applications or interesting clients using this. And I think, don't quote me on this, but I think actually Microsoft is using this with Airbus, and that's to detect anomalies in aircraft sensors. So you can consider that's a highly critical application. If there are anomalies in aircraft sensors, I'm pretty sure you need to know, because that is you don't want to mess with faults in an aircraft. So you need to be on the ball as soon as they occur. So I would definitely say, yeah, definitely run data series from highly critical applications. I've run this on multiple the API on multiple sources, and it seems to work pretty well. So I would definitely try it.
Okay, awesome. I think that's all the questions from today. So we'll see you next week, same time, same day, with another episode. And thank you very much for today.
Thank you very much, guys. Feedback is always appreciated. So definitely send us your feedback. An episode will occur next week. It'd be great to know your feedback, to see what you liked, what you didn't like, so we can continuously improve these series.
Great. I think Jack's come back with another question, if you don't mind. What is the max payload for that entire series request?
Okay. I think I don't. Okay, so I think the maximum number of samples you can pass through the method is 864. But you could easily find that in the documentation. But it's around 864 samples that you can pass through at any one point in time, which is more than enough, in my opinion.
Okay, perfect. Well, thanks, Nick. We'll see you next week. And thanks, everyone, for joining. Have a great evening or rest of the day.
Have a great evening, guys, or rest of the day. Yes.
All right,
See you.
bye.
Bye bye.